So I'm going to tell a story. It's a true story. Unfortunately, Callan, it happened more than once. I'm learning to drive. We had a garage that was detached from the house. And I open the garage door and I back out and I put it into park. And then my dad came in and said, all right. And we have a very, very, very long driveway. And I'm really nervous. And we have to back out onto Highway 42, which connects Plainview to Wabasha. And so there are a lot of trucks that come through. So I'm a little nervous. And I turn my head like I'm supposed to. I put it in gear, step on the gas, and go right through the garage door. Not a great thing. Because the same thing had happened at the age of 13 with a snowmobile. But I went through a different garage door at that time. Okay. So, what makes this tough are there instances in calculus in which we got to go back and forth. So sometimes we head the wrong direction and go through the garage door, okay? I am still alive. I am a very capable driver on the road. That was just a moment in my life which I now can tell that story and think it's rather humorous. Okay? Not when I was 16. So what we're going to do is you'll be given a graph and you will be told, hey, this is F. Draw its derivative. You'll be given the derivative and go backwards and have to draw F, okay? So we're gonna do some of that practice thing. And we're gonna give you some hints here. The first one is focus on the slope of F. Now the slope is F prime, the derivative. And we're looking at all the y values. And this is just being a little bit redundant. Slope of F is the y value of the derivative. Alrighty. So, there are steps that I go through. This is F, correct? And F has a relative max and a relative min. Those are the first things that I take a look. It goes from, and when I do that, and I'm going to change colors, I think. Yeah. When I do that, you'll see me make some type of notation here. Either I put a dot there, or I put a little tangent line. That's where the derivative is what?
0.
0. So I come over here and I mark those 2 zeros. I know my derivative has to go through those 2 points and only those 2 points on the x-axis, because nowhere else is there a tangent line that has a slope of 0 on that graph. Does that make sense to everybody? All right, now, from this interval right here, f of x is increasing. Correct? What does that derivative mean up to this point?
It's increasing, but the rate at which it's increasing is decreasing.
What does it tell you about the sign of the derivative? It's positive. It has to be, correct? So it means the derivative has to be above the x-axis until we get to that 0. Here is where the derivative is above the x-axis, or what we call positive. Notice that between these 2 red dots, f is decreasing. within this interval. What does that tell you about the derivative? It has to be what?
Negative.
It has to be. It has to be below. Now, here's the thing though. I'm at 0, I gotta get negative, but I gotta get back to 0, correct? How does that happen? I know I have to be negative. As soon as I get past this 0, I gotta be below this x-axis, but somehow I gotta get back to 0. What has to happen? It's gotta turn around, right? So if you take a look, see how F is concave down here? And then it's concave up here? That means there's an inflection point. Would you agree? And an inflection point on a derivative is a relative min or max. So there's got to be a turning around point somewhere in here, and it's going to match up with this inflection point. So right here, my derivative.
Oh, yeah, you're drawing the derivative on it?
Pardon?
You're drawing the derivative on it? On the thing?
I am. The red line is the derivative.
Oh,
This is f prime. And then if I take a look, once I get to here, I have 0. From this direction on, f is increasing. That means from this direction on, f prime's got to be positive. So it's going to increase like this. And if you think about it, f looked like a cubic. I don't know, does Mr. Karsh use the word cubic? It means it's a polynomial with a degree of what? 3, right? So f, I don't, ignore that. F, I got an eraser. F has to be something, you know, some coefficient with 3, with a bunch of stuff after it, right? That means its derivative would be 3ax squared plus a whole bunch of stuff after it, right? This is a graph of a cubic. This is a graph of a parabola. It will be, if you use the power rule, it goes down 1 degree, correct?
that means that means for the next one, f is going to be a quadratic?
Are you talking about the derivative of this?
No, for the next one.
We should get something that looks like
Like
a
something,
quartic.
yeah.
A quadratic is power of 2, a quartic is a power of 4.
Oh,
Okay? Okay. Is everybody with me on that?
I think so.
Okay. Now, I'm going to be doing more than one. All right. So let's take a look at this. Tyler, what's the derivative of that?
6x.
Ariana, what's the derivative of that?
6x.
Jonah, what's the derivative of that?
6x.
6x. Now, they all have the same derivative, correct?
Yeah, because they all have the same slope.
I would agree. What happens that creates, why aren't they different? What happened to each one of these? Something went away. Cal,
Constant.
the constant, because the derivative of a constant is 0, right? And if you remember, when you add or subtract a function, it moves it up and down, correct? Okay. So, we're gonna be reversing this one. But, we don't know where it is up or down bent. So that means your graph could be a little bit different than Owen's graph. Could be a little bit different than my graph. Because we don't know how it slid up and down. Because we know the constant was eliminated when the derivative was formed. Is that making sense to everybody?
So this is integrals.
What?
This is integrals.
We're headed that way.
Yeah.
Okay? All right, so. Let's identify, and then I'm gonna draw the picture down below here. So, I'm gonna draw it like this. Here's my y-axis. Here's my x-axis. Now, Matthew brought up a good point. If this is a cubic, I know the degree is gonna go up. It's probably going to be what we call a quartic, okay? Which means it possibly could cross the x-axis 4 times, right? That it's an even function. The branches go up together or go down together, like a parabola does, right? All even ones, to the squared, to the 4th, to the 6th, will have that. All right, now, what are the important things on this? This right here is important. Remember, this is the derivative, correct? What is that spot exactly?
Max of the
It's a what kind of max?
relative.
It's a relative max. Is it a relative max? Let's look at it.
It's a relative min.
He disagrees you.
Oh yeah, relative min.
It's a relative min,
Yeah.
right? Because the derivative here is negative, so that means f is going down here. F is going up here, correct? So this is a relative min. Now, where is that relative min? I don't know. I just know the x value. The relative min could be here, it could be here, it could be here. I don't know where it's up or down because I removed that when I took its derivative. Right, Callan? They're gone. So you can't be wrong where you have the relative min. I'm going to put it here. Why? I don't know. I like it. And it's a relative min. So I know I have this, right? I want it to look a little curvy. Oh, excuse me, it's a relative min, it's going down. Because this is negative, f is going down. Now, what do I know about this? Yes?
It is a point of inflection, I believe.
It's the point of inflection of the derivative.
Yes.
Okay, but this is the derivative. What is it in terms of F?
That is a good question, one I don't have an answer to.
Okay, anybody know?
Relative max.
Yeah, it's a relative max.
Oh, yeah, that makes sense.
Because you're going from positive to negative. So, somewhere on the x-axis, I have a relative max. I don't care where it is. So I'm gonna put it here. Now, again, this is the derivative. What is that?
Now that might just be a point of inflection.
It's a point of inflection on, right? Because the derivative is going from increasing to decreasing. All relative extrema of the derivative are points of inflection. So about here, that means I gotta have a change of concavity somewhere. Now, don't make these pointed because there isn't anything that's undefined. So I'm trying to make it curvy. I'm trying to show that this is concave up. I'm trying to show this is concave down. What's this right here? Audrey, what do you think? Relative something. Relative min. So, I can put that relative min, again, I'm gonna kinda line it up. And I can put anywhere you want, I'm gonna make it so it's kinda nice, so it's kinda symmetric. I'm gonna write that this was a point of inflection. What is this? Point of inflection. Which means there has to be a change of concavity. So this is concave down, it's gonna have to change to concave up, and then it increases after that. Kinda looks like a W, would you agree? Quartics look like W's, except they're curvy, they're not pointy like a W. You doing okay? All right. Colin, that would be a graph of what? F of x equals x squared. The graph, that's a graph of what? Tell me what it looks like. Describe it to me. Parabola? Where's the vertex? Okay. Is it going up or down? Looks like that. Everybody agree? Okay, Ben, what is its derivative?
2x.
2x. What does that look like?
It's linear.
Okay, more specific.
Passes through the origin.
Very good. Anything
Slope
else?
2.
Slope of 2. Which is just more than a slope of 1, right? Slope of 1 cuts those quadrants in half, so it's a little bit more than that. Would you agree with that?
Yeah.
Okay? Owen, what's the second derivative?
2.
2. What's that look like?
Flat line. Horizontal.
Horizontal line where?
Y-intercept 2.
Perfect. I like how you said that, intercept 2. Okay? third derivative.
The jerk.
What's it look like?
Non-existent.
What's the derivative of 2?
0.
How do I draw the graph of 0?
That's the neat part. You don't.
Yeah, you do. It's already there.
Exactly.
What is it?
0.
Yeah, it's a line, right?
Yeah, it's a line
Horizontal line where?
on the x-axis.
Perfect.
As I said, you don't draw the
So I'm making it a little bit darker. That happens, oops, you can't see that very well. All right. Let's say I give you something like this. You go, oh my gosh. And what we can do, we're gonna graph that on the calculator. I'm gonna use my TI first, and then I'm gonna switch over to my Casio. So I'm gonna go y equals clear. Make sure my plot buttons are all off. You guys know that, right? They gotta be clear on top, otherwise stuff gets really crazy. And I'm gonna type in sine, parentheses. Oops, I don't need the parentheses, it's already there. Let me try this again. Sine, second, not second, e to the x, where is it? Oh, second ln, x, parenthesis, parenthesis. And let's look at my window. I think my window's okay. I want negative 10 to 10, just like that, just a standard window. And I'm gonna graph it. Oh, that's terrible. So I'm gonna change that window.
Yeah, I just did the trig function, do the trig view window for my Casio.
Okay, that's good. I'm gonna go from 0 to 2 pi. And I'm gonna make that negative 3 to 3. Yeah, that's a lot better. In fact, I think it's too long, so I'm going to change my window even more. I'm going to make this second pi divided by 2. Yeah, it's simpler, it's not so crazy. So I went from 0 to pi over 2 on x and negative 3 to 3 on y. Everybody okay with that? Are you able to do that on your Casio, or you want me to show you how to do that? Matt, you.
Well, I got it like this.
Okay, but can you shorten it down, just going from 0 to pi over 2, so it doesn't get all those crazy wavy lines? Everybody else okay? Alrighty, so I'm gonna go to y equals. I'm going to come down here, and I'm going to show you how to make your derivative. So it will graph the derivative for you, okay? And so I'm going to go to math, and I'm going to go down here to line 8. If I have a TI, then I'm going to go to vars, and go to y vars, and choose y1. So I'm saying take the derivative of y1. If you're a TI person, you're going to have to put a comma x, because you're saying take the derivative
Oh, so for
in terms of x.
how do we do this on Casio?
Yes, very much so.
How do we
And
do
I'll
this?
show you in a second. Okay. And then TI people have to put in this, rather than a number, we're saying compute the derivative for every x, parentheses, so it needs to look like that. Now you may have that d, right? Correct?
Yep.
And so, if you put that in, I think it's gonna look like this. Here's your d, do you have a parenthesis?
Yeah, it's D over D and then into something in parentheses.
Yeah, and there's a little box down here.
I just put X in there.
Yep, you put your variable x in there.
And then for the next one I put Y1.
Yep.
And then it's just, at the end of it goes X equals something, and you can put something in the X.
And that's where you wanna put that x.
Okay.
So is it kinda like that?
Yep.
Yeah. That's exactly, you explained that really well, okay? I gotta buy myself a nice TI calculator, I just haven't one to pull the plug. All right, if you got a Casio,
I think I got it.
huh?
I think I got it.
You think you got it?
Is it option?
Yes, if you go to
Count.
option,
On the option calc, you go to D over dx, then
Correct.
in parentheses, you
Yep.
go to vars
Yep.
y1 comma x.
you got it. Okay, did you get that? Did you get that? Do I need to do it on mine or not? Okay, so now I'm gonna hit graph. Now, just to let you know, because this is an old calculator, it's gonna take a little while to do some thinking. I'm gonna hit graph. I guess it wasn't as bad. All right, so this is the oops, came back up. Okay? So this was the original function. This is its derivative. Well, first of all, what does it mean with that derivative being above the x-axis? Yeah,
It is concave. No, it's positive.
yeah, and so that means that y1 was doing what from here to here? It's
going
what?
up.
It's increasing, correct?
Yes.
And right here is a relative max, so somewhere right here must be a relative max. So what I can do is I can go second trace, and I can take a look at my relative max. And I know it has to be somewhere to the left. Enter, somewhere to the right. Enter, enter. And I got 0.4515813. Is that what you guys got?
I just went G solve max.
Yeah, your the Casio's a little bit nicer, but did you get
Yeah.
the same number?
And the derivative is 0.
The derivative is 0, and it'll say that on your calculator. So in other words, if I think, yeah, notice I just put the down arrow on my Casio here, and I went straight down. Notice that's the x value, isn't it? There's my relative max, there's my, so you can get information from your calculator. Is that making sense with everybody?
I think
You're
so.
able to draw the derivative on your calculator. Colin, you got any questions or everything okay?
Everything's good.
Okay. All right, let's go back to this. Then, all right. I'm gonna draw F here, and I'm gonna try to do a good job. This is F.
Better than I did it.
Callan, tell me one thing about my beautiful drawing, besides that it's beautiful. What's happening? Tell me something about F.
It's increasing.
Ah. Okay. So what does that mean about the derivative?
That's positive.
It's, my graph has to be above the x-axis, correct? Would everybody agree? Okay? You wanna keep going? You wanna talk about anything about concavity? Okay, good. You wanna talk about concavity?
It's changing concavity in multiple of these two
Yeah,
places.
what is it right here?
Concave down, then concave up, then concave down once again.
Would everybody agree? Okay? So, what does that mean, Owen, about the derivative when it is concave down?
It's greater than 0? Or no?
It's greater than 0 because f is increasing. So now I know f is concave down. What does that mean about the derivative? I'll give you a hint. Can I give you a hint? What can you tell me about the second derivative?
It's less than 0.
Yes. What does that mean about then?
Oh, it's decreasing.
Yes.
Yeah.
I knew my hint would work, okay? So, if you look then, when it's concave up, what would you tell me, Owen? How would I fill this in here?
It's increasing. Or, yeah, it's increasing.
Okay, and I'm just trying to draw the derivative, aren't I? So I'm giving myself little hints. Okay? Now, there's an inflection point, correct? Would everybody agree? Where there's an inflection point, this happens. You get a horizontal tangent line. There's supposed to be one here too, but I did a lousy job in drawing it. For a moment, that graph flattens out. F flattens out, okay? Now, why are those important? Because they're going to tell you the derivative is going to be what there?
0.
0. Okay? So I know it's 0 right here. I'm going to get my red pen. And I know it's 0 right here. But it doesn't cross because Callan said, hey, the derivative is positive because f is increasing. So it's one of those that hits the x-axis but doesn't cross the x-axis. Is that making sense to everybody?
Could you explain that again?
Okay, this function is always increasing, except for those moments where it pauses and flattens out and then continues to increase. Okay?
Okay.
That means the derivative has to be 0, but isn't going to cross over from positive and negative because the function is always increasing.
Therefore, there are no relative extrema.
Okay? So, here's my derivative. This right here again, this is f. So what does that got to be right there? Goes from concave up to concave down. What's that got to be? It's got to be an inflection point, correct? Right here, it goes from concave down to concave up. Would you agree? So right here, I gotta have an inflection point. I'm gonna call it IP. Are you okay with that, Audrey? Now, what are those in terms of the derivative? Right, what? They're relative extrema. It's where the derivative changes direction. So, remember that when I go concave down, the derivative's gotta be decreasing. So I'm gonna start it anywhere, it doesn't matter where I start it. It's gonna be decreasing, and then it's gonna hit this spot, where it's 0, and then it's concave up, which means it's gotta be increasing till it gets to this inflection point. And then it's concave down, so it's gonna be decreasing. And then it's gotta turn around because it, well, I guess just say it's concave down. But eventually it would change directions. That's as far as I got here.
Yeah, my graph will not make any legible sense to me.
Okay? So this is what my graph looks like. All right, last one. What can you tell me about f prime?
Is it increasing?
It's increasing. The entire time, correct? So that means f prime is increasing, excuse me. And what else can you tell me? It's increasing, everybody agree? What else?
It's positive.
It's positive. Those are the two things you can tell me. All right, so over here I have F. If the derivative is increasing, what does that mean about F? Excuse me, I'll say it again. If the derivative is positive, what does that mean about F? It's increasing, perfect. If the derivative is increasing, what does that tell me about F? If the derivative is increasing, what does it tell me about F? Here's the derivative. It's increasing. Let me try it a different way. What does it tell you about the second derivative?
It's positive.
Positive. What does it tell you about the function?
Concave up.
Concave up. So, that means this is concave up. So I'm gonna draw F. It's gotta be increasing and concave up. Bingo, I'm done. Okay, I'm gonna give you two assignments. We're gonna work on them today and tomorrow.
So tomorrow's a work day on it?
Yep. Okay? And what I want you to do is compare each other's